All right, guys. Green on the left, notes on the right. All right, so our next, and believe it or not, our last lesson of this chapter is the real number. It's on the real number system. All right, so we're going to talk a little bit about the real number system. Actually, some of it we've already talked about coming up to this point. Now we're going to add some things to it to talk about the big picture of things. All right, so with our vocab, we have two vocab words today. So the very first one is irrational number. Everyone?
Irrational number.
So if you don't remember, we've talked about rational numbers before. What's the prefix ir mean? Not. Basically means not, right? So here's the definition they give. An irrational number, it's a number that cannot be expressed as a over b, where a and b are integers and b does not equal 0. Okay, that's the definition. Very similar to when we talked about what a rational number was. So an irrational number, it's a number that cannot be expressed as a over b. So here is, we'll talk more about this in a bit, but here is something to put over in your little box there. A non-perfect square root. Talk about square roots. A non-perfect square root, like the problems where we've had to estimate, those are considered irrational numbers. Now, it's been a little while, but we have talked about this before. The next word is a real number. Everyone?
Real number.
All right, and your definition in the book says it's the set of rational numbers together with the set of irrational numbers. So, I think when we were talking last time about certain things like whole numbers, we talked about them being like elementary school numbers. Well, a real number we'll call all 7th grade numbers. So you're going to see almost all these in 7th grade. All right, so this next part, you can sit back, partially relaxed, but you need to keep your brain warm. You need to make sure you're listening. Okay? You don't have to write this down unless you want to. I do need eyes up here. I do appreciate some of us trying to get our vocab numbers in there, our page numbers, but right now I need eyes up here because this is actually part of the lesson. All right, here we go. When you're really young, you start, and this is going to sound like a lot of you because we've talked about a lot of this before. When you're really young, for example, my daughter's 4 years old right now, and I'm sitting there and we're actually working with her on some basic numbers. Actually started addition subtraction already. She's only 4, but even when she was younger, when you guys I'm sure were younger, when you first learn numbers, what do? You start counting. And when you count, you're like 1, 2, 3, 4, 5, just your basic, what we can call counting numbers. Okay? So what I'm going to do is I'll put like something like this. 1, 2, 3, and just dot, dot, dot. Okay? I'm going to put a circle around it. Okay? Those type of numbers, like when you first are really young, okay? These, besides called counting numbers, these are called natural numbers. So everything like that you can count on the positive side of the number line, whole numbers, right? They're called natural numbers. Now, probably before you started school, but usually doesn't come natural when you're counting numbers. There's something that's added to it, and that is the number 0. Right? When you count as a kid, when you're little, you don't go 0, 1, 2. I never hear that, right? It just sounds kind of odd. But this 0 here, I'll actually put it on this side. Okay? This is part of a bigger set of numbers called whole numbers. Okay? So 1, 2, 3, 4 are called natural numbers. You add a 0 to it, and it's called whole numbers. Now, I want to share something with you guys before we move on. Okay? Is that, remember, 1, 2, 3, and so forth, those are all natural numbers. But they are also inside this circle as well. They're also considered whole numbers. 0, and we've talked about this in a lesson a while back, right? 0 is a whole number, but it's not inside this circle. It's not considered a natural number. It's just a whole number. Okay? 1, 2, 3 are natural numbers and whole numbers. Then you get to 7th grade. And that's when we start dealing with the left side of 0 up there on that number line. So something like -1, -2. I'm going to write it left because it's kind of like a number line. -3. I'll put dot, dot, dot that way. It's kind of weird, but this, okay, this is called integers, which of course we've talked about a lot. So let me review again. 1, 2, 3 are natural numbers. They're whole numbers. These are also integers because they're in the integer circle as well. But on the other hand, right, integers are those, but those numbers right there are not whole numbers or natural numbers. Okay? Then we get to, oops, this box here. That box is in all of them. But these things, of course, you actually learn some of these in elementary school before you even learn integers. And these, okay, are called rational numbers. And we talked about that earlier this year, right? Rational numbers include stuff like 1/2, fractions, -3/4, negative fractions, okay? Decimals, 45/100ths. They actually include stuff like 4/10 repeating decimal, okay? Those are all examples. Believe it or not, and you'll see it in your book later, even something like a percent, like 18% can be considered a rational number. Because why? Well, you can convert it to a decimal point. So again, 1, 2, 3 are natural numbers, whole numbers, integers, and 1, 2, 3, 4, whatever are rational numbers. But these here are not considered integers, whole numbers, or natural numbers because they're outside of those circles. So you have to pay attention to what circle or box, in this case, these certain numbers fit in. And that's what you could define it as. Okay? These are all rational numbers. Now comes this little side box over here. And this little side box is what we call irrational numbers. Here's some irrational numbers. 1.2136485. It's a decimal that goes on forever. It doesn't repeat and it doesn't end. That's an irrational number. Here's a symbol for an irrational number. You may remember this from elementary school. Pi. Pi is actually 3.14 and it keeps going on. It does exactly this. Here's another irrational number. Square root of 3. It is a non-perfect square root. Talking about that, a rational number, right, can be something like square root of 4. Because you can simplify that, it becomes 2. Now, this whole box right here, both little boxes, this whole big box, they are called real numbers. So that's the title, of course, of our lesson today. So we're going to be talking about all of these sort of things, all of the numbers. Whole box. Okay, questions on any of that?
What's the difference between whole numbers?
What's the difference between what? Zero? That's it. That's the only thing. You add it. You put a zero with the natural numbers, and it's not called natural numbers anymore. They're just called whole numbers. That's the only difference. Good question. All right. Any other questions, guys? Okay. Go ahead then, and let's go ahead and grab our book. Oh, by the way, if you're writing this down and you've got it all down, great. If you're trying to play catch up, don't. This is on book page 174. Okay, that's why I told you to sit back, relax. I want you to listen and think, but you don't need to. It's already in your book. You can refer to it when you're doing your homework on 174. Okay. All right, so here we go. Let's go ahead then. If you haven't already done it, grab your book. Let's go over some examples that you'll see on tonight's homework. Some kind of questions they'll ask you. So grab your book, take out a piece of lined paper, first, last name up at the top, period, assignment number, book page. Okay, if you haven't already done it, go ahead and grab your book and turn to page 177. Okay, by the way, you will need your calculator today. You will need your calculator. All right, so I made a quick little mistake. I want to make sure I clarify this. I think I was going a little too fast, and of course we've talked lately about going fast, right? I put square root of 3. I was mainly focusing on that being an irrational number, but a rational number are these except this. Square root of 4 isn't. Let me say that again. It is a rational number. However, what's the square root of 4 simplified to? It's also considered a natural number. Okay? Because its equivalency, when simplified, is just 2, which is a natural number. Any question on that? Sorry, I didn't want to confuse you guys. I'm looking forward to the examples, I guess, and wasn't careful about it. So. All right, here we go. Let's go ahead and take a look at page 177. Problem number 24. 24, the directions, guys, are extremely important. We've got to make sure we're reading them. It says, name all sets of numbers to which each real number belongs. Right? Natural, whole, integer, rational, or irrational. So number 24 is square root of 144. All right, listen. These should be very quick for homework tonight because of this right here. I gave us a little reminder. Look at the page 174 diagram, which is this right here. Just refer to this. So find out where this is, or an example that looks like this. And actually, we just talked about that, right? Square root of 4. Why is that like that? Because I know that square root of 144 simplifies to 12. So 12 is a natural number. So 12 is a natural number. I'll just put the word natural. I'm okay with that. But listen, ladies and gentlemen, it's not just a natural number because it's right in the center. It's also in the whole number. It's also an integer. And it's also a rational number. It is not an irrational number. Remember, that's why that's a separate box. Okay, you don't have to call it a real number because all these numbers that we're dealing with are all real numbers, okay? So if you're going to talk about this, I'd say step star is if that's a there's a radical sign on it, square root, okay? Then simplify it, okay? And then step 2 is carefully, I'll even put a little asterisk or a little star on that, meaning carefully look and use the diagram on page 174, okay? Just refer to it the whole time. Because you cannot, when I say carefully, make sure you're not leaving any of them out because you'll get it wrong. Okay, so be very careful. All right, questions on that? Gotta have you guys try one. Okay, shouldn't take you guys very long. Let me get my timers out. All right, here we go. Problem 18, go. Okay, anyone need more time on that one? 30 seconds, turn to your neighbor, share, see if you guys have the same answer. Go. All right, so it's under the same heading. That means that it is. Have the same directions. So they give you guys a little tricky here, right? It's 36, negative 36 over 4. Don't forget about step star. Can we simplify that? Yes. To what? Yeah, negative 9. So now if we're going to match it up with our little diagram down here, where would negative 9 go? It'd be right here. It'd be in the integers. So be careful though, right? A negative 9 are part of these negative numbers, but also it's inside the rational number box, so it is also rational. Okay. I did hear some people having a really good discussion, all right? So those of you that didn't have it right, any questions? Okay. All right, let's go ahead and let's go to another type of problem. Let's take a look at page 177, problem number 32. Number 32. Okay, I'm going to take this off because we won't need the chart for these kind of problems. So, number 32, the directions say order each set of numbers from least to greatest. So on 32, they give us the set of 2 and 71/100 in bar notation, 71 repeating, 2 3/4, square root of 5, and 5 over 2. Step 1. We talked about this yesterday when we were kind of going over our homework and we had our class discussion. You need to convert everything to look the same. So, I mean, you can convert decimals to fractions. I wouldn't recommend trying to put everything in square roots, right, with a radical sign. But more than likely, most people would prefer putting it in decimal. And so that's how I'm going to do it because I believe that's how you're going to do it. But you can put it in all in fractions if you like. I'm going to convert it where they all look the same. Well, the nice part is that this one's already a decimal. This one here, it should be middle math for a lot of us, right? 0.75. Square root of 5, that is not a perfect square. Now, someone asked me yesterday, they said, Mr. Wilkins, how do we use our square root button? Okay, so your calculator will do one of two things. You have to play with your own calculator a little bit. Some calculators, especially the higher level calculators, are like little mini computers. Most of the time, you will need to hit your square root button, the number that goes in. So you'll hit actual square root 5 and hit equals, and it'll give you the answer. If you have a calculator like this one, okay, you'll hit the 5, and then you hit the square root button, and it gives you your answer. So play with yours a little bit. Find out, doing this problem here, which one that yours will do. Okay? More than likely, most of yours will probably look like this, where you hit the number first and then hit the square root, and it'll take the square root of that number. The computer ones, you'll kind of, it's almost like writing it down. Square root of 5, and you'll hit equals, and it'll simplify it. Okay? So in this case, I've got 2.23. We know it's irrational. We know that the digit's going to keep going. So what you might want to do is, I'm just going to round to the nearest hundredth here. I'm sorry, thousandth. Actually, you know what I'm going to do is I'm going to round to the nearest hundredth. And here's why. Because both of these are in the nearest hundredth. I just need to remember that this one's rounded. That one repeats in case we have any that are very similar. All right. And then 5 halves. 5 halves I know is 2 goes into 5 2 times with 1 left over. It's 2 1/2, which means this is 2.50. Okay? So we converted them all to decimals. Step 2. Put them in order, and in this case, right, this one says least to greatest. So, there's no negative, so we don't have to worry about how the negatives look differently, you know, because they go the opposite way on the number line. Okay, so the smallest, they're all positive, so the smallest right here is 2.24. The next one is 2.50. The next one is 2.71 in bar notation, and then 2.75. Sorry, I was trying to squeeze it in, but I don't want to squeeze it any longer. Step 3. Put it in its original form. Guys, this is crucial because especially with tests, multiple choice tests, they're always going to have it in original form. So you need to put it in the original form. So the 2.24 ended up being the square root of 5. The 2.50 was the 5 halves. The 2.71 in bar notation was exactly that. That we didn't convert that. That was already like that. And the 2.75 was the 2 3/4. Okay? Questions about that before I have you guys try one? I'm not going to be too picky about that. There will be a time this year where we kind of get into more detail about those, so don't worry about that. Thank you for asking, though. Okay, guys, other questions? Okay, this will take you a little longer. I'm going to start off with 1 minute and then check in with you guys after that. All right, so 1 minute. Go ahead and try out problem 34. 34, bless you. Go. Okay, anyone need more time on that one? All right. Those of you that are already done, just continue on with your work. We've now done 2 different types of problems, so you can get a big portion of your homework done. Okay, checking in. How many of you still need more time? All right. I'll give you guys about another 20 seconds or so, and then I'm going to have you guys share. Okay, 30 seconds. Go ahead, turn to your neighbor and share. Go.
I got negative 3.4, negative 3.3, negative square root of 10, then negative 15 over 6.
All right, so number 34. Okay, the set was negative square root of 11, negative 3 3/10 in bar notation over the 3. We have negative 3 4/10, and we have negative 16/5. All right, so let's start with this. I want to start with some answers here. All right, so ordering them from least to greatest. All right, so seat 39.
34, I got negative 3.4, negative 3.3 with bar notation, and negative square root of 11, and negative 16 over 5.
Okay, agree, disagree? What do you guys think? Okay. A lot of agreements, some disagreements, some people looking around to see if they can go with the popular vote. I hope not. All right. Anyone want to share theirs? Okay. No? Okay. So here we go. I'm going to convert, right? So decimals. Decimals works out. So the negative square root of negative, or the negative square root of 11. All right, so let me go ahead. I put 11 in, punch my square root, and there it is. So it's negative 3.3. As of it looks right now, I could leave it like that. I know that the next one is, maybe I put a 1 here, because this is going to be negative 3.33. Okay, and that, of course, is just what I just said. Negative 3.3 in bar notation. We have a negative 3.4, and then this here, right, is, and actually you could even punch this in the calculator. This is a negative, and then 16 divided by 5 gives us 3.2. Now remember what we've talked about. We just talked about it yesterday. We've been talking about it. I reminded you on that last problem just briefly was The number line goes the opposite way. All right, so for example, when I talk about whole, I always call them whole negative numbers, but they're just negative integers. If you take a look on that side, negative 15 is smaller than negative 6. Okay, even though 15 looks bigger, right? It's the opposite way. So meaning that whatever looks the biggest, the largest, is actually the smallest because of the negative value. So the one that looks the largest out of all these would be that one right there, negative 3.4. The next one, if I compared both of these, this is, remember, negative 3.3 rather than negative 3.1. So this would look larger than that, which means it's actually smallest. Then comes that one, negative 3.31. And then, of course, negative 3.2. And if I was to convert these, that one, of course, so negative 3.4 is up there. This one is actually that as well. Negative 3.31 was the negative square root of 11, and negative 3.2 is the negative 16/5. So those of you guys that got that answer that was given to me, which was the majority of you guys, okay, you end up getting it right. Okay, those of you that were kind of like this and not quite knowing and just kind of looking around, okay, ask your questions. Okay, so when you guys don't ask questions, right, I'm assuming that you've already realized what you did wrong, okay, and you now understand and you just don't make the same mistake again, right? So there are no questions. All right, let's try one more type of problem here. Here we go. Let's take a look at problem 36. We are going to start solving equations. All right, so watch this. Number 36 is y squared equals 64. Now, we haven't gotten into equations yet, but I know that you guys did equations in elementary school. Okay, as a matter of fact, I think you get all the way up to two-step equations in 5th grade. Okay, so let me just give a quick review. I'm only going to do one-step equation today. If we had, and I'm going to do a simple one, all right, if we had this. Now, yes, I know x is 2. We're going to admit that, right? It's not the number, the answer we're looking for. It's the process. If I need to solve what x is, I do the additive inverse, or in this case, I do the opposite of plus 1, which means subtract 1. And then you do it to both sides of the equal sign. What that does is this cancels out, and this gives us x is equal to 2. Okay, those are the steps that I'm hoping that your elementary teacher taught you, because that's how you solve equations. Okay, so taking the exact same steps, I have y. 1 isn't being added to it, it's being squared. I need to do the inverse. I need to do the opposite. Here, the opposite of plus 1 was minus 1, or positive 1 and negative 1. What's the opposite of square? Square root. Okay, we said when I taught you guys square root, it's the inverse of a square. It's the opposite. Whatever I do to one side, I do to the other. Whatever I do to this side, I do to this side. Now, just like plus 1 minus 1 cancels out, a square and a square root cancels out. So we end up with y. The square root of 64 is 8. So, step one is find your variable and do the opposite to it, the inverse. All right, we'll get more into this later. Step 2 is do the same thing to the other side of the equal sign, the other side of the equation. Step 3 is simplify. So the opposite of squaring is the square root. What's the opposite of cubing? Cube root, right, what we've talked about, right? Any questions? Try this one out. Problem 38. All right, how many of you need more time? Okay, 30 seconds. Turn to your neighbor and share. Go.
I got 11.
Okay, I just double check.
All right, here we go. Answers. Let's take a look what you guys got. Here we go. C36.
So the answer, I have P equals 11.
P equals 11. Agree, disagree? What do you guys think? Oh, a lot more people for sure. You guys are sure of yourself now. All right, let's check it out. I'm hoping that it's 11. Here we go. So P is being cubed. I'm going to take the cubed root of this side. I go ahead, do the same thing to the other side of the equal sign. This, of course, cancels, so that's how we end up with the P. So far, Caleb is good to go. Cube root of 1331. Normally, right, you do a little bit of guess and check, okay, unless you have a cube root button on your calculator. All right, but I'm going to go ahead, since you guys gave me 11, let's check it out. 11 times 11 times 11 equals, ta-da. So yes, P is equal to 11. All right, questions? Nicely done on that last one, guys. Okay, any questions, even on this middle part? That's the one I'm kind of worried about, the ordering. We kind of struggled with that the other day, too, on our homework. We're okay? All right. So, real number system.